Hello student, very good morning to all of you. How are you? I hope you all are happy, healthy and fine at home. Do you remember what were we discussing yesterday? I think we were discussing about the commonly observed electrophilic substitution reaction. I think 5 commonly observed electrophilic substitution reaction we have seen. First one is a nitration reaction. We are getting as a nitrobenzene, then sulfonation, then halogenation, Friedel-Crafts alkylation, Friedel-Crafts acylation, and then diisocoupling reaction. So today what we are going to discuss, because we are talking about the general mechanism of electrophilic substitution reaction, we are before that we are what type of the reaction generally that aromatic compound can form. And as we know that in the first case there is a formation of the pi complex, how the pi complex is formed. And as we know that benzene is a nucleophilic in nature, and when it approaches to the electrophile, and then there is a formation of the pi complex over there, right? So that pi complex exists, that type of the pi complex we cannot isolate, but its existence is proved by using the iodine. There is a change in color, and that is the only evidence, or what we can call it as a proof for the existence of that pi complex formation. Okay, and now next point we are going to learn about the general mechanism only, formation of the sigma complex uranium ion. What do you mean by, one more question may appear, I already told you that. What do you mean by, or what is a sigma complex? Sigma complex means what? Generally what is happening there, as we know that in the second case here benzene, as we know that, right? Benzene double bond over there, and now when it is attached to the electrophile, and what you are going to get? You are going to get here, when this electrophile attached to here double bond, suppose over there. So what is going to happen here, when suppose let us see here this is attacking over there, and what you are going to get here, a double bond, here is a double bond, and the electrophile is attached over there, right? Electrophile, and with that one of the hydrogen atom. Now when this double bond shifted from here to here, what is happening there? There will be a positive charge present over, and this type of the complex is known as sigma complex, or it is known as a uranium ion. This is called as a sigma complex, or it is known as a uranium ion, uranium ion. And this is uranium ion is nothing but is a aromatic carbonium ion or carbocation it is, that you remember. And even though it is a sigma complex, even though it is a non-aromatic in nature, but this is stabilized due to the resonance. How it is stabilized? Let us see over there. Now how it is stabilized, even though it is a non-aromatic in nature, but it is stabilized due to the resonance over there. Here I am writing as it is a hydrogen atom. Now as we know that resonating arrow shown by the double-headed arrow, that are the resonant. Now what is happening, this double bond is shifted from here to here, neutralizing that positive charge, so that you are going to get over here this double bond shifted from here, and now the positive charge comes on that carbon atom. This is a double bond over there, it remains as it is. Here is the electrophile, and these hydrogen atoms are there. And now again we can shift this double bond from here to here, neutralizing this positive charge, and you are going to get this one, the double bond. This double bond is already there. Look at here, this is a double bond here, and now when this double bond shifted from here to here, positive charge comes on this carbon atom. This is electrophile, and this is a hydrogen atom here, right? Or we can write this structure like this. So there is a positive charge and there is a electrophile and that hydrogen atom. So this one is stabilized due to the resonance. And now how will you prove, what are the evidences for the existence of the sigma complex? How will you prove? There are some the existence of this what we can call it as this sigma complex is proved by using the mesitylene. The formation of sigma complex has been proved by actually isolating it is in some cases. This type of the sigma complex, existence of sigma complex is proved in some cases. Let us see what are those cases here. How will you prove that one? So number one, first one, what is happening there? In the first case, mesitylene, the mesitylene, as we know that mesitylene when treated with ethyl fluoride, when treated with ethyl fluoride, as we know that first one is this is a structure of mesitylene. This here is a methyl group, at this position also methyl group, this is as a methyl group, and this structure is known as a mesitylene, right? Mesitylene, which is a common name of this compound, and that will be treated with ethyl fluoride in presence of BF3 as a catalyst, that is a tribromofluoride at minus 15 degrees centigrade, and the resulting compound is I think minus 15 degrees centigrade. What you are going to get here, there is a this type of the compound is formed over there like this. Here this methyl group they are as it is, this methyl group also as it is, and here the ET group is introduced over there, and this prove that the existence of here the HF and BF3 over there, BF3 and plus that is a catalyst over there, HF and plus this one is used as a catalyst, and this prove the existence of this. And now when this mesitylene is further, this compound further treated with Me, this one methyl group, this is also as a methyl group, when it is treated with BF3 minus 50 degrees centigrade. This is at room temperature, and here this is treated with the same reagent ETF in presence of BF3 minus 50 degrees centigrade. Then the product is formed over there like this. This is a methyl group, here ET hydrogen atom, and for sake of convenience you can write here is a positive charge, and this positive charge will stabilize due to this methyl group. Here we can write as a methyl group over there, and this is a existence of this group is proved over there, BF3. And now if heated at room temperature, what do you get? You will get as this type of the product over there. But this is uranium ion is proved by using as this reagent. Another one, the sigma complex is following reaction have been detected by NMR spectra. This compound again detected by the second proof or the evidence for the existence of the uranium ion. What is that? That is detected, second one is detected by the NMR. NMR spectra. NMR spectra means what? NMR, nuclear magnetic resonance, which we are going to learn in the 4th semester, in the next semester. That is it is a very good modern technique for the determination of the structure of the unknown organic compound. So that we will see. But here just we are going to prove the existence of that. Here the fluorine, fluorobenzene treated with HF, hydrogen fluoride, in presence of antimony SbF5, in presence of sulfur dioxide. What it gives? It gives the compound is like this. The compound is formed over there. Fluorine, here is a positive charge hydrogen, and this is a hydrogen plus Sb plus SbF6 minus charge over there. And this is also proved that is a sigma complex is detected by NMR. Sigma complex detected by NMR. Detected by NMR. And as I already told you that NMR means what? Nuclear magnetic resonance. So in this way we have seen there are the 2 evidences that prove the formation of rhenium ion. So now the last means 3rd point remaining here. What is that? That is a 3rd point we are going to see over here. 3rd one, because we are talking about the general mechanism of the electrophilic substitution reaction, the aromatization of a sigma complex. See, aromatization of sigma complex. Aromatization of sigma complex, that is a rhenium ion. Rhenium ion. We are using the word rhenium ion frequently, aromatization of the sigma complex, because just now we have seen as the existence of the sigma complex. Now why that aromatization? And as we know that aromatic compound, after the aromatization, that is a driving force to lose that hydrogen atom, and we are going to get the aromatic compound over there. And therefore sigma complex, which is non-aromatic, undergoes a loss of H plus R generally to form the product in which the aromatic nature of the ring is retained. So in aromatization, what is happening over there? Let us see here. Generally double bond here and another double bond here. Here I am writing as a one hydrogen atom, and here electrophile here may be as a positive charge. And while doing that aromatization, this is a, what is that? This is a sigma complex, right? Sigma complex, or which is known as a rhenium ion. Rhenium ion, right? And aromatization takes place means there is a loss of proton from here. This proton is lost and form as a double bond over there, and you are going to get the product formation is this one. This electrophile get introduced. So some commonly reaction we already seen. So in this way we have seen the how that existence of sigma complex, or how aromatization there is a loss of H plus over here. The strong electrophile loses as a weak electrophile. That is a product with the aromatic ring. This is a product with aromatic ring. Product with aromatic ring. Product with the aromatic ring we have got over here. And now the complete mechanism then can be shown in two stages, and therefore now we can able to write the complete mechanism of the electrophilic substitution reaction in the two step. First step, here we can write first step, as we know that this is a compound, right? There is a hydrogen atom, and then attack by electrophile over there, electrophile, and this is known as a, what is that? Step first, attack of electrophile is a step number first, attack of electrophile, attack of electrophile, attack of electrophile takes place. And what is happening after attacking as a electrophile? Generally I am writing as a properly here, and let us see, here is a double bond should be written in a proper way. Here double bond I am putting, another double bond and another double bond, so that we can first, when that electrophile approaches to the aromatic compound, first one form as a pi complex, right? This is called as a pi complex, and that pi complex further is converted into this one. The electrophile is attack either this side electrophile, here H, and positive we can say here is a positive charge, and this double bond and this double bond, this is nothing but as a sigma complex. This is a general in the first step is formed over there, how pi complex is formed and the sigma complex is, because first one is a pi complex is formed, and that existence of pi complex, when it is treated with iodine, there is a change in color that indicate that there is a pi complex form, and then after that, that pi complex is collapses into as a sigma complex, and existence of that sigma complex is proved by using acetylene is treated with the ethylene fluoride in presence of the in presence of the BF3, means trifluorobromide, and resulting compound we can detected that isolated that sigma complex. Another example we have seen, that is fluorobenzene when treated with the hydrogen fluoride, and there is a formation of the sigma complex is detected by the NMR spectroscopy. So these are the two proofs. So this is the first step. Now the second step, what is the second step happening here? As we know that this one, in the second step, here electrophile, hydrogen atom, this double bond and this double bond. Now here there will be, here is a positive charge, and when this hydrogen atom is lost over there, this step is known as a aromatization. And aromatization, there is a loss of proton, and we are going to get the formation of the product over here, the formation of the product. So let us see properly whatever is shown in the first thing, so don't get confused over here. Here just here double bond, this double bond, they are as it is, and here is a double bond, and here we are going to get as a electrophile over there. So these are the two steps. This is step number second is a aromatization. Step number second is aromatization. Step number first is the formation of the pi complex, and is further converted into as a another one. So these are the two things are happening in this case. Now, and here the general, whatever general reaction, mainly as a 4 reaction of 5 or I think 6 reaction we are going to learn, all that are following this mechanism. This is a general mechanism of electrophilic substitution reaction. In the first step, what is happening? Attack of the electrophile over there, and we are getting as a formation of the pi complex, and that pi complex is further converted into as a sigma complex, and then the last step is aromatization, the driving force behind it, the aromatization. That this molecule is non-aromatic in nature, and it trying to stabilize over there, and therefore aromatization is the second step, and you are going to get as a this type of the product over there. I think with this we have seen as a general mechanism in three parts. Number first one is the formation of the pi complex, how pi complex is found. Number two is the formation of the sigma complex, and number three is a aromatization of a sigma complex, means rhenium. What is rhenium ion? That also you have to remember. Rhenium ion is nothing but as a carbonium ion are the aromatic carbocations are there. And so in this way, I think let us stop today here. Remaining we will see next time, that is the effect of substitution, group orientation and the reactivity. Thank you. Have a nice day.